Good morning. So we are actually gonna get started working today. Let's figure out what we're doing. That's usually what we want to do first. So what do we got on the list for today? Well, got a couple things. It looks like what we want to do is convert our player movement to blueprints, and we also want to convert the FatSec AI to blueprints. So let's start off by converting our player control logic to blueprints. Let's close everything. And I'm just waking up, so might be a little slow. We're just getting into this. But right now, basically, we've got this Dashkin biped movement CC class, which has our virtual controller, and then basically checks our virtual controller to see like which actions are being taken, and then calls set wanted velocity and direction for our movement. So pretty much, we want to move all this stuff out into blueprint land. So right now, it just kind of looks like this, and we got our logic in C++. And we want to change that. So let's figure out how to do that. All right. So basically what we want to do is we want to make a, what is this? This is a movement object. We want to make a movement object which, because let me, I'll pull open the documentation for some of this stuff that I wrote. I'm definitely waking up, jeez. I'm like, what am I doing? So, basically what's going on is this Dashkin actor, this kind of player proxy actor, is pressing buttons on this virtual controller, which is on a Dashkin actor, and our logic controller should be accessing those virtual controls inside of blueprints in order to actually control this entity. So that we're using this biped movement CC is not what we want. This is the movement controller component thing, and the movement controller is not supposed to be telling the movement controller what to do. The logic controller is supposed to be reading the virtual controller and then telling the movement controller what to do. Like, the logic is supposed to be where we have our brain, not the movement. The movement's supposed to be, you know, the body. It figures out what to do based on what the brain says. The brain's supposed to figure out what the brain is supposed to do. So we need to get our logic groups set up there. So what we should do is kind of make our short list of stuff that we need to do. So we need to override the logic object with a player blueprint. And then we need to implement that player blueprint. Alright. So let's take a quick look at what we got here for actually creating our player object. See, yesterday we got to the point where basically we had our logic object for our player with our initialize, create, destroy, and all that sort of thing for our player. And we got two players. We've got our bitey player proxy, and so it's our bitey player proxy, which has our actual stuff on it, and we're saying we want the player logic object, and our movement controller is nothing. So we should use the base movement controller and the bitey movement data for the actual bitey object that we use. Okay. So, what have we actually got going on then? We need to, first off, disable whatever is creating the biped movement CC, which I think is our movement controller component. Yeah, we've got like if movement is null pointer, then create a new one. Otherwise, create a Dashkin fatsack movement object. So we definitely need to do what we were doing before. We need to be cloning. These things. So let's see. If our movement is null, then we need to create a base Dashkin movement object. Alright, so basically if movement does not equal null pointer, then we need to clone what was actually passed to us. Because U-assets are kind of pointers to a single kind of just piece of data, and we need to copy it. Because we have an actual class with actual temporary variables and all sorts of stuff like that. I want to do that inside set parent because that's kind of our initialization code. So what do we need here? Yeah, the fatsack movement is actually the thing that's powering our fatsack right now. We're going to change that as well. So basically we need to go to the logic controller component, which is where we were actually doing some of this work before. So what we need to be doing is we need to be passing in our movement object to our movement controller component when we call set. So we should be calling set we should go and set parent here with our class Dashkin movement object, and we'll call it movement. So if movement does not equal null pointer, then what we're going to do is we are going to set movement equal to new object, and this will be our base movement. I should change that name so it's a little bit more true to what it really is. So it's base movement. Basically, to clone something, you call new object, you pass in the owner, and the owner is going to be this component itself, and you give it a class that we want to make, which is the base class, base movement. We're cloning it, so we want the same class. Then we give it a template. This template will be used to fill everything out. So if our movement still equals null pointer at this point, then we probably want to just go ahead and make a base movement class, which would be, because we need a movement object regardless of what this thing is. So if there's nothing, we're just gonna grab the default for our stuff. So we want the Dashkin movement object. And we don't want any template for this. And then we want to remove these things. And the reason we're doing all this inside of our set parent is so inside of begin play and all these other methods, everything's already set up. So if our movement still equals null pointer, then we're gonna do like a warn log here. Unable to create any movement object for our object. Alright, so now let's make sure that our set parent here, this entity controller component set parent, is probably getting called by our Dashkin entity actor. Yeah, so definitely movement here, and we're having to do a bit of boilerplate code just to get our stuff up to date, because we're now kind of cleaning up our stuff here that should be working, but we didn't have everything set up properly yet. Alright, so we need proxy get. Yeah, it's this entity movement, I believe. So when you look at the player proxy real quick, make sure we've got the right stuff on it. This is the entity proxy, sorry, not the player proxy. So we've got our movement controller object on there, so where are we actually getting that? That's get movement controller, so it's this movement object. So movement is going to be this get movement controller object right here, and we should just pass that down the chain. Dashkin entity actor, we're going to need the post setup method. We're going to need to change that so it actually takes this dude here. And we're actually gonna remove a few of these things that, yeah, we don't want this movement object existing on our entity actor itself, just because we don't want to have a whole bunch of copies of stuff hanging around. We want something to own the data, not just have like everything own all the data all the time. We want something to actually be the authority on it. So we're going to make sure that it is, we pass stuff to the movement controller component, and the movement controller component figures out like all the things to clone and all the things to that it needs to actually do. So that's what we're cleaning stuff up. And it might not make a whole lot of sense to people watching. Yeah, that one's fine. Alright, so we've got all these things. Alright, so post setup is going to call set parent on this thing and all of that sort of stuff. We're going to call initialize with our actor, and what's the logic controller component? We need the movement controller component. So set parent should do all the things. And do we need initialize? Doesn't look like it. We're setting our parent in here, and everything should be fine. So our movement controller component, let's actually look at our movement object. We have set owner, and that's it. So we're calling set owner inside of here. We should actually just be, we can just do that. So we don't have an initialize call, we just have a set owner call. Maybe we should make this the same as our logic controller, just so we don't have a confusing thing. Like, we just call this initialize. Because the logic controller and the movement controller they're kind of mirrors of each other. They do different things, but they should have the same sort of life cycle. Alright, cool. So we've got that roaming along. That's looking just fine. So we should make sure it all compiles and that we can actually do a few things. We're also going to want to change we're going to need to be able to assign. Well, we don't need the movement controller stuff assignable to blueprints. We're kind of doing the opposite at the moment. We probably don't need to blueprint the movement controller stuff. Because most of that will be inside of movement controller object. Yeah, this no longer exists. Wow, I am a bit scattered at the moment. I should definitely be initializing a lot of these things. I've gotten lazy. Alright, so what is this? Initialize for the movement object itself, movement data base, duplicate. Dashkin movement object. We have initialized. So we have get movement data is no longer a thing. This is your movement data, and we're cloning that movement data. So I was a little hasty in some of this. Yeah, we want the movement data. Movement data is different. The movement data is the actual, like, you can run at 5 meters per second. So, looks like get physics components by type. Yeah, it used to be right here. I'm just looking back into Perforce, and I can just very easily get a diff of what I'm looking for. Like if you've never used version control before, this is what the file used to look like, this is what it looks like now. So I'm like, okay, I shouldn't have removed that. I just go back into my history, and I can just go look it and find it and add it right back, no problem. Alright, so initialize. So no problem. So basically now what should be happening is nothing should be moving, which is what should be happening. Because nobody's telling it to move. So let's confirm it. That's right, I can't move or do anything now. Which is exactly what should be happening. Let's make sure we don't have anything in our logs which is angry at us. Nope, nothing. So basically what point we're at now is that we aren't randomly making crap. This should be going off of our Byte player proxy object, which is going off our Byte object, which has no movement controller. Well, I mean, it's got a... What does it have? Let's just look at it real quick. Byte player proxy has got no movement controller on it, so if we switch that to Dashkin biped movement, now we should be able to move. Cool. Okay, that's working exactly as we want it to. So when you set that to none, when you save that, our logic controller should be our player logic object, and that should be fine. So what we need to do now is we need to make it so that our player logic object can actually access all the functions it needs to in order to actually access the virtual controller and stuff like that. So right now our player logic object, like you can see, I don't think we can actually do too much inside of it. So like inside of update, what we want to do is we want to, what is it that we actually want to do? We want to basically, we're trying to duplicate this sort of functionality here, where we call on our parent, we want to call get movement and get our movement object. That'll allow us to set our wanted velocities and our directions and all that sort of stuff. What's our move det actually doing here? Our jump velocities. So we need to like start making a lot of utility methods on ourselves, so that inside of blueprints we can actually fetch all the things that we need to fetch. That's what it looks like. So what are the things we need to get? We need to get for movement data, we need to get our animation controller, we need to get all the things. We also need to, where should we throw everything? Well, everything should probably just have a pointer to the Dashkin entity actor, and the actor should kind of act as the pawnbroker for everything else. So I think basically we want to get our actor, and our actor should be able to give us everything we need. So what we should be doing is going to our Dashkin entity actor, making sure that it has everything accessible from blueprints. And it looks like we pretty much already have all that. So let's see, let's just double click. We have our movement data, we've got our movement object. And we need to make sure all these things are blueprint callable. So get entity, get flipbook component. We should probably start renaming a few of these things. Make them shorter if we could. So it'll be like get flipbook instead of get flipbook component. Let's just, you know, continue, get anim. Let's just call it get anim. Because we have long names and stuff like that, it's going to get real annoying. So we're not actually going to need the controller components that much. So get movement controller. We should be getting the actual objects. Okay, so like get movement data is fine. Get movement. It should be like get movement controller base, how about just get movement controller component? Should be that one, but we need like this get movement. This should be like our actual movement controller. Maybe we should call these, instead of like get movement controller, we should just call movement controller? Eh. The logic object should get logic controller. Logic controller component. Let's see, get physics components. Alright, yeah, that should be accessible as well. Get physics component for type. Sure, that should also work. Alright, so our entity actor now has access to just about everything. Now we need to make sure that we have access to our actual entity actor. It's going to be inside of logic. It's going to be our logic object. We have our parent. So it's going to be like get entity actor. So probably some U properties that are accessible. I'm not super blueprint man, so I'm not sure exactly the standard way for exposing like a U property to everything. I think it's a, let's look it up real quick. So it should be blueprint read write. So we should be setting up like should be like a blueprint read, and then category is like Dashkin for this, and we should probably just call it like entity or something. So let's go to our logic object. We're not even setting our parent to null to start with. That's not good. So we should do entity null pointer, and basically we're replacing imparent with entity. We want to do that for all of our logic objects. We should, our logic object, our logic state should have a an entity object as well, so it's just easy to get everything all over the place. So the logic state has one, and the logic state group should have one. State group, alright, so we'll go from the state group, initialize, logic object parent, we're going to say entity equals imparent, get let's get entity actor. logic state, initialize. We're probably going to have to fix some compile issues, so we will do so. I'm beginning to notice a trend where nobody wants to watch coding in the morning. At least, so is it blueprint read? Like I need to actually look up the U property blueprint read write and see if there's a blueprint read. It's just read only. Okay. Because we don't want this thing actually setting any of our stuff. Logic object. Do we have entity? Blueprint read only. Logic state. Blueprint read only. Logic state group. Blueprint read only. Let's just make sure we can fetch our objects now inside of our blueprint, so we can basically create that. Get logic controller conflicts with. Yeah, this should be get logic controller component. Cool. Yeah, and refactoring C++ can take a little while, especially just it's not very easy to refactor the language. Maybe I'm just doing it wrong, but I've never found it easy to change stuff in C++ land once it's kind of set, because it just takes forever to fix issues, and it's not like in other languages where you can just be like, oh, well, what reference is this thing? And have it actually be able to get you that information. So yeah, with blueprints you cannot have duplicately, two functions that you can call from blueprint with the same name. In C++ you can do that, just overloading functions, which is nice because you can be like, well, I can have default variables and a whole bunch of different functions named the same thing, and it just kind of works. It's used all over the place. Dashkin logic object is not, so I need to include that. So how to include Dashkin logic object.h. Another fun thing with C++ is header files and getting all that stuff set up properly. We're having to change all sorts of stuff. Hooray, refactoring code. Always the most fun thing in the world. Yeah, and this was this awful code that we had written beforehand. And we're going to be able to throw all this stuff out into Blueprint pretty nicely, hopefully. Because that's pretty much what we should be doing, is setting up all of our things so that all of our real logic that does anything with the game is inside of blueprints, and all of our kind of heavy lifting code that actually needs to be efficient, or code that needs to do a whole bunch of complicated crap, we're going to throw all that into C++ land where we can maintain it a lot more easily. And then all of our other stuff we're going to put into blueprints for actually doing things like, oh, well, this little AI should face right and fire guns or whatever. At least that's the plan. At the moment. That's kind of what you do with scripting languages. You want to make the scripting language simple, easy to work with. Instead of being like, oh, well, you want to implement pathfinding? Yeah, do it yourself inside of visual scripting languages. Like, thanks, I'd rather not. I'd rather use a real programming language for that. It's just easier to organize. So let's pop open our player logic controller. So we should be able to call things such as, is there like entity? Yeah, so there's like get entity, which is a Dashkin entity, and I should be able to call get virtual controller on this. I'm going to throw this over on my right monitor, my main coding window that is. Alright, so we want to get the virtual controller. Basically, okay, it's like this is console. Yeah, we need to check if the console is open, and if the console is open, we don't want to grab the updates. So I need to go to Dashkin console utils real quick. No, utils.h. Piece of crap. Is console open? Is not what I want. Already, I have to do it. So, yeah, we'll be basically. I need to go back through all the things and expose them to blueprints as we find them. console and console. Alright, now we gotta recompile everything. And this will kind of be what we're doing. Hello, Carcan. Good morning. I have not been up too long. Const F string directory. Ah, stupid. Yeah, I can't. Blueprints are a little bit limited in everything that they can do, so it kind of makes sense that we're gonna have to actually call all of our stuff properly. We're gonna have to do a few things. So this is taking a const. I'm gonna swap these two. I am doing well today. Just woke up not too long ago. It's like in the morning actually, so what a concept, being up during the light hours of the day. Alright, so if directory dot is, what is f string? I want to see basically if the f string is empty, I'm just gonna call the other function with a null pointer. So like a length, it's just len. Directory.len equals 0. Then we're just gonna return execute command null pointer. Otherwise, we're gonna return execute command with a command and then address of directory. Yeah, it's 6:30 in the morning at the moment. What's on the menu for today? That's a good question. Basically, I'm overriding the logic for the player so that we can see what the player does in blueprints, and then we're also going to be implementing FATSX AI in blueprints just to make sure that the blueprint stuff works. It's mainly a proof. Like, we did all that work making all the blueprint stuff yesterday, and today we are proving that we actually did all that stuff and that it actually does work properly and that it's useful. And we're doing that by actually starting to use it. First thing we're doing is the player, then the crappy FATSX AI that I wrote in C++, and then once we can do that, then it's pretty much good. We may get there. We're not really going for super amazing. We're just going for basics at the moment. Alright, so we want to check. Our first thing should be like, is console open? So if it is open, we need like an if. So if it is open, we want to do nothing. So we just, we'll just return. And I am not sure how to organize blueprint code to be maintainable or useful or any way, shape, form, or fashion. good. So if anybody has any suggestions, I will not get offended. Basically what we're doing is we need to see, we're going to need our virtual controller. We're going to need our movement controller. So we're going to need entity, whoops. We're going to need get movement controller. And maybe we could just kind of do stuff like this. We're also going to need the movement data, so it's going to be can I set a variable? Variables, get reference to self. Oh. Because I guess it's more... Alright, it seems like I should definitely have a get movement data method here. On the entity itself. Do I already have one? I do. Okay. So we can get rid of these things. So these are all like our getter functions to get all the stuff that we're going to use. And we want to see a couple things. So if our... We need to get our virtual controller. And we need to push this into a is key down. And we're looking for the left stick up action. So if our key is down for left stick up, then we need I need a variable here, like a temporary variable, which is a direction vector. So how do I do that? I need like f vector. How do I make one? Let's call this direction vector, and it should be an f vector. It's like a structure. F vector. It's just called vector. And this is also me, like I have not used visual scripting language stuff before. So I don't know the patterns that I'm supposed to be using. So basically, yeah, we want to set this thing to... We want to figure out which way we want our character to go. So if our up action is true, then we want our I want to add a vector to this thing. And I'm not even sure how to do that. This is really funny, actually. Let me just look it up. How to add to... Let's just add to Y in blueprint for vector. While I don't know the way to set them individually, you can split the input pin on the set node so you don't need to make vector. To do this, right click on the vector input. It's like, did they say right click on the input pin on the set? Split structure. Recombine struct. Okay, so it's like if this is true, then we want to like set direction vector. Well, I don't want to set these to 0, I just want to set one of them to 1. I just want to like add 1 to 1. I don't want to... Yeah, it's like set only one variable on vector in blueprint. It's like I just want to set the z to 1. You think that would be easy, right? Maybe I'm kind of doing this wrong. Maybe I should be doing something else, like basically I need to create like a temporary variable or something. I just need a constant. I just need like a number here. I could do it in materials.